Hello guys, welcome to another brand new tutorial series on building a real-time chat app using Socket.io. So if you're a student still in college or if you're a working professional, you can consider building a chat application because that can really make your portfolio pop out. So the way that I've structured this playlist is that first off, we will learn the fundamentals of WebSockets. Okay, so we're not going to touch Socket.io. So that would mean we first understand the WebSocket native browser API, which is on the browser side. And then on the server side, we use a package called WS. So both of these are low level. We are not going to use any libraries like Socket.io. And the reason why I wanted to talk about the low level stuff first, because that would form a very good foundation. After that, we will learn how the client and the server communicate using the socket protocol using events. We will then look at the popular socket.io library, the benefits of using it over the native API. We will also build a primitive application with vanilla JavaScript, Node.js and Socket.io. In the second part of the series, we will build a real-time chat application. For that, we will be using React.js, Express.js, Socket.io. I'm really excited about this video, so let's jump right into it. Alright, so to first understand Socket.io and WebSockets and everything else, we first have to understand something called the socket protocol. So before we start talking about the socket protocol, let us first understand what HTTP protocol is. Okay, so HTTP protocol is something that most of us will be familiar with. So in an HTTP protocol, so if our application in the web browser wants a particular data, so what does the client do? The client makes a HTTP request to the server. If the server thinks that the client is authenticated and authorized to access that particular resource, the server is going to send a response back to the client with that particular data. So essentially what I want you to take away from this is that the connection is not always present. It is only established when the client wants something. Right? So we have a get request, we have a post request, put request, delete request. So anytime the necessity or the need comes on the client side, only then the connection is established. So that is what a HTTP protocol does. So let us now talk about what is the WebSocket protocol. So the WebSocket protocol is slightly different. So the first two steps is the same thing as we saw right here. The diagram does not explain it, but basically the handshaking happens between the client and the server. Okay, and then the connection is opened. But in WebSockets, instead of a request and a response happening on demand, what ends up happening is that there is a bidirectional connection, an open and a persistent connection that is opened or established. Okay, and this does not end at all. It is always going to be open. Here is an analogy to help you better remember it. Let's come back to the HTTP protocol. So the way that this works, you can relate it to how emails work, right? So somebody sends an email to somebody else, and that other person, in response to this email, sends an email back to the first person. But in WebSockets, you can think about it in terms of a phone call connection. Right? So for example, when you call up somebody, the connection is open and persisting. It does not close up. You can talk to each other in real time. It is always open and persisting, right? So let us actually go to the MDN docs and search for WebSockets and let us see what they have to say. So a WebSocket API is an advanced technology that makes it possible to open a two-way interactive communication session between the user's browser and a server. Okay, so it is a two-way interactive communication session. So with this API, so this is a browser API. Okay, so you can actually access this WebSocket API right within your browser. So with this API, you can send messages to a server and receive event-driven responses without having to poll the server for a reply. So what does this polling mean? That is what HTTP requests do. That is called long polling. We are polling the server for a particular data. Right? We don't have to do that with WebSockets. It is purely driven through something called events, which we will talk about in the upcoming sections. So without wasting any more time, let us jump into writing the code. For the backend setup, firstly, we will work with low-level utilities without using any high-level frameworks like Express.js or Socket.io. And the reason why we're doing this is based on my experience of having taught a lot of students, without having a foundational strong knowledge about WebSockets, they really struggle to build complex applications. So once we're done with that, secondly, then we will introduce the package called Socket.io, and then we'll use Express.js as well. So to get started with the code, make sure that you've installed Node.js in your application. So just hit Node.js, go to this first link, and then make sure that you've installed this right. Okay. And secondly, you might also want to install Visual Studio Code right here. Okay, so this is the text editor that I'll be using in this video. So you can go ahead and install it if you have not already. And that is exactly what I've done here. I have just created a folder called WebSocket in my computer, and I've opened it using Visual Studio Code. So let us actually go ahead and create a folder called server, and let's create another folder for client. So this is what is a monorepo. Essentially, both the client side code as well as the server side code sits inside of the same directory. All right, so let us first start with the server side code. So let me go to the terminal. Also make sure that your Node.js is installed. You can test it out by typing node-v, which stands for version, and you should get a version right here. Okay, let's go into the server directory right here. Okay, so since we are building a Node.js server inside of this folder, let's first do the npm init. So it is going to ask you a bunch of things. Let's hit enter for all that. Perfect. So we get something called a package.json file. So along with this, let me also create another folder called app.js. Perfect. So this is the file where we will be writing the socket server. Okay. So to set up the socket server, I'm going to install this package called WS. So I'll tell you what this WS means. Coming to npm WS, click on this first link. This is a go-to package for working with WebSockets on the server side. So this WS stands for WebSocket. Okay, so WS is a simple to use, blazing fast and thoroughly tested WebSocket client and server implementation. Also, another thing that I want you to note is that it is very low level. Okay, so it does not have as much complexities as socket.io. So now that WS is installed, I also want to install something called NodeMon right here. Okay, so NodeMon is just something that helps us with hot reload. So every time we make some changes to the server code, we don't want to stop the server and start it every single time, right? We want it to automatically do it. And that is what NodeMon helps us with. So if I go into package.json, you can find that we've got both NodeMon and WS sitting inside of here. Ideally, we would want NodeMon to move to a developer dependency, but for the purpose of this tutorial, we can leave it as is. All right, coming back. So let us now actually go ahead and instantiate the socket server. And to do that, what I'm going to do is I'm just going to say const ws. I'm going to require ws right here. And next up, I can instantiate the WebSocket server. So I'm going to say ws server. Okay, so sometimes you might also have an HTTP server. So to differentiate between the two, I'm going to call it WebSocket server. And the way that you can instantiate the WebSocket server from here is that I can say new WebSocket server. Okay, that is it. And this method takes in an options object, inside of which you can actually specify which port you want the WebSocket server to listen to. So in this case, we can have it as 3001. Okay, this should be good enough. And next up, I'm going to make this server listen to a particular event coming from the client side. Okay, and the event that I want the server to listen to is called connection. Okay, so I'll tell you what it means. So I'm going to say WebSocket.on, and then I'm going to listen to an event called connection. Okay, so anytime there is a client getting connected to the server, this connection event is going to trigger. So that is what this on means. Okay, so as soon as the connection is established, there is a callback that is getting triggered. Okay, so this could be the callback. And inside of this callback, we also get an argument which we can call as socket. So what is this socket object right here? So to understand this better, let us look at a very simple diagram. Okay, so what we have is a server in the middle and there are multiple clients, right? So these could be browsers, these could be mobile apps, right? Think about WhatsApp or think about Facebook Messenger, right? So anytime there is a client that is going live, right? So anytime these clients load up, if there is some instruction in the client side code that says anytime there is a client that is loading up, connect it to this particular server socket. As soon as the client is loaded up, there is a socket connection that is being made. Okay, so just think about it as a tube or a pipe. Okay, this is called a socket. All right. Similarly, if this client loads up, there is a socket connection that is established from client to server. So the server can communicate with the client can communicate with the server. So as soon as the connection is established between the client and the server, this particular connection callback is going to be triggered. Okay, so that is what this particular event means. Similarly, we've got other clients as well. Also, I want you to notice another thing. As you can see, all these socket connections, I've painted it with a different color. Okay, and the reason why I've painted it with a different color is that even though these are all socket connections, they all have different socket IDs. And this is very important. Only if the socket connections have different IDs, only then the server can differentiate between different clients. Okay, so this particular socket connection is unique for this particular client and the server. So the blue socket connection is unique for this particular client and the server. So now that we understand pictorially how socket connections work, let's come back to the code, right? So as soon as the connection is triggered, we have the socket object right here, which is going to contain several information about, let's say, this particular socket. This could involve ID and a lot of other things. All right. Now, so after the connection is established, I also want the server to listen to any messages that come from a client. Okay. So I want the server to listen to any messages that come from any of these clients. So the way that we can listen for those messages is by saying socket.on. Okay, so this is the socket that we're using right now. So anytime a particular client sends a message, we are listening to the message event. And every time there is a message that comes, we trigger a particular callback right here. And whatever message the client sends, we receive it right here. So let's call it data. So right now, let us just log it to the console like this. Let's now build out a very simple front end. So let us create an index.html file. So right here, if you hit the exclamation mark and hit tab right here, this is an emmet abbreviation, which is going to give you the HTML boilerplate. So first off, let's change it to WebSockets. So in HTML, this is what I want to build. So essentially, I want to have a text input right here, and I want to have a button right here as well. Okay, so whenever the user enters a particular message and hits submit, we want that particular message to get logged as a list right here. So let us not worry about the logic right now. Let us just build out the UI first. Okay, so the first thing is I want to create a form right here because this entire thing could be considered as a form. So inside of this, we want an input field. We can have a placeholder as enter your message. And we can also have the type as text. Okay. And the next thing is going to be a button. And we can call it send. And let's also not forget to mention the type of this thing to submit. Okay. So to run this particular HTML file, I'm going to use something called live server right here. If you do not have live server, quickly just go on to the extensions, search for live server. So just go ahead and install this. So once you're done installing the live server, if you come back, you should be able to see a button right here called Go Live. Another way to do it could be to right click and you can also find Open with Live Server right here. So let us click on it. So you can see that we've got an input field and a button right here. Let us also add a little bit of CSS to this page, although you do not have to absolutely need to. So I'm going to come down here, create a styles.css file. Let me paste some CSS code. I'm not using any sort of class names or anything. I'm just purely working with forms, inputs, and buttons. So the code for the CSS, it is in my GitHub repository. I've attached the link of my GitHub repository in the description below. So you can just go in here and copy paste it. And finally, let us link the style sheet in this index.html file. And this is going to be style sheet. And we can add the href to the styles.css right here. So let me save it and come back, and you can see that we've got a very nice UI. All right, let us now move on to writing the JavaScript code. So the first thing that we want to ideally do, we have to initialize the socket connection at the very start. So to do that, let us use the WebSocket API that is available right within the browser. So we can say const socket, and then we can just say new, and then WebSocket. Okay, so this is the API, the browser API, similar to set timeout, similar to a lot of other browser APIs like fetch. This is another browser API. We can make use of this, basically telling our application that as soon as you load up, connect to the socket server that is right here. So right here, we know that the WebSocket server is running on port 3001. Okay, so we have to specify it on the client side JavaScript. So we can do that by saying ws /localhost 3001. Notice that we are not using HTTP here because we are not working with the HTTP protocol. We are working with the WebSocket protocol. All right. Now let us include this particular app.js in here. So we can say script source, and then we can say app.js. Okay. So you can immediately see that the connection established message is getting logged on the server side. So what ends up happening is as soon as this particular web page loads, you can see that there is another log here as well, right? Because this client is getting connected to the WebSocket server right here. So the next thing that we want to do on the server side is that we want to be able to catch any messages that is sent from the client side, right? So let us do that. Let's go to the client right here. Let me close the other things. You can click on close others. And now let's write a very simple function right here, which is send message. Okay. So this can take in the event object here. Within this particular function, we want to grasp the value that is sitting inside of this input field, right? So firstly, let us grasp the element itself. So we can say const input. We can get access or reference to this particular input field by saying document query selector, query selector, and then input. And before we send this particular input value into the socket, we also have to check if the input value is actually having some value and not just an empty string, right? So if you worked with any messaging apps like WhatsApp, you will know that you cannot just send any empty strings, right? So let us actually check if the input has any value at all and it is not an empty string. So if it has some value, only then we have to send some information through the socket. So you can send information through the socket to the server by saying socket.send. And in here you can say input.value. As simple as that. So let us now trigger this particular function on the submit event. Okay, so if you come down here, we've got the form right here, and anytime the send button is clicked, this form's on submit event is going to get triggered. So let us actually first get a reference to this form, and we can get a reference to this form up here. So we can say form document.query selector, query selector, and then we've got the form right here. And now we can say form.add event listener, and we are listening for the submit event, right? So we're listening to the submit event. Let me pull this down, and this gives us a callback function. So as soon as the submit event is triggered, we can call this callback. So ideally we can just like remove this and use this particular send message here, right? So this would pass in the event object. Also, another thing is we want to prevent default this thing. Okay. So let us actually give this a whirl. We are getting the input value and then we're sending it through the socket to the WebSocket server. So as soon as we get this particular message, it should get printed in the terminal right here, because that is what is running right here. Okay. So let us actually do it in the client. And also let's make sure that we are not getting any console errors. It is saying that it cannot read properties of null, reading add event listeners. So what it is saying is that JavaScript is not able to get a reference of this particular form. Okay, so the reason why that is happening is that we have to defer this particular script. This script, this app.js script is getting loaded before all these HTML elements are getting mounted onto the DOM. The form element is still not yet mounted onto the DOM, so it is getting as undefined. So the defer keyword, what it does is it is essentially telling the browser, wait loading the script until all the HTML elements are loaded. So now if I reload the page, you're not seeing any sort of errors here. Let me try saying, hey there. So if I hit send, if I come down here, you can see that there is some information that is getting printed. Okay, so let me go back to the server code. So essentially what is getting printed is a buffer data. Okay, so whenever in a socket connection, information is exchanged with each other through buffers. It is a stream of data. So if I wanted to decipher what this means, I just have to do one simple thing. Okay, so we can call it B. And then here we can use the buffer.from method right here, and we can pass in the data. And also just to make sure, let us also make it as string right here. So if I print this out, and let me now try to do the same thing again. So I'm saying hello world or something like that. And I've hit send. And now you can see that this particular message is getting logged. Now that we've received this particular message from the client, I want to send this particular message back to the client. So as soon as we enter this particular information and hit submit, this text is going to the server. Now the server has that information. Now I want the server to send the information back to the client, and then I want the client to add that information in this list. Okay, so it is not directly coming here, it is going to the server and the server is sending it back to the client. So we're doing this because we want to understand how events work in WebSockets. Okay, let's come back. So now let's send this message back to the client. So to do that, we can simply say socket.send, and we can do something like this. Okay, and whatever information that we want to add right here, we can add it. But right now I'm just going to send whatever message that we get to the server back to the client. Now, so we are sending this particular data from the server to the client, but we now need some way for the client to capture this particular data and then append it to the list down here. But just writing this particular piece of code is not going to do anything right now, right? So if I say, hey there, I hit enter, nothing happens right here because we now need to capture this particular message on the client side. We still have not done that. So doing that is very simple. So I'm just going to say socket.addEventListener, and now we're listening for this event called message. Okay, so we've got the socket connection right here. We're listening for some message that we get from the server right here. Okay, and we get a callback here as well. So this callback gets the event object, but inside of this event object, we want the data that is being sent. Okay, so we can call this anything that we want, but here we get a property as data inside of this object. So let me destructure this particular data right here. So let me console log it out, and you should be able to see the same message that the server sends back to the client. Okay, so what ends up happening is the client, we are entering some data right here. We're sending this message to the server side code, and then the server side code is sending that message back to the client. And now we've written code to capture that message right here. Okay, so let me say message received from the server. Let me give a little bit of space right here. Okay, so let us try it out. Hey there. Perfect. You can see that we are getting the same message right here. So we know that this particular code works fine. So here's the next thing that I want to do. So if I come back to this, I want to create this particular thing programmatically. So first off, let me just create a simple UL right here. And inside of this UL, if I create another LI like, hey there, think of it as a text message. And now you should be able to see this particular thing. Okay. So now we want to programmatically add this LI to the UL. So coming back to the client side code, so we get the data right here. Let me first get a reference to this particular UL right here. So we can say document dot query selector UL. So the next thing is we want to create an li element. So we can also create an li element by saying create element like this. And we can also mention that we want to create an li. So now that we've created the li node, we now want to add the text content of this li node to data. Now all that is left is to append this li as a child to this particular UI. So we can say ul.append child, and we can add in the li right here. And that should be it. Let's give this a whirl. Refresh. You can see that the connection is again established. Let's say, hey there, Harish. Hit send. You can see that it says, hey there, Harish. So this, although is a little bit weird, every time ideally after the user sends a message, we want to clear this out, right? So let us quickly do that here as well. So as soon as the message is sent, we want to say input.value is an empty string. So let's give this another whirl. Hey there, Harish. Perfect. You can see that it is working fine. Also right here in the server, you can see that we only have the WebSocket server right here, right? But what if you also want an HTTP server, right? What if you want both of the servers to listen to the same port? You can listen to the same port. We can have both those servers listen to the same port because they both operate under different protocols. So that is possible. So there are a couple of ways to configure the socket server. So if you're coming from a Node.js background, you should know that we can easily set up a HTTP server alone. So right now you can see that we've set up the socket server alone. But if the situation arises, both the HTTP as well as the socket servers, and we can have it to coexist but on different ports. And we can also have it listen to the same port as well. So if we wanted both of these servers to listen to different ports, what I can do is I can come up here, I can say const HTTP, and then I can require the HTTP module. So using the HTTP module, I can create the HTTP server right here. Okay, so how can you create the HTTP server from this module? You can say http.create server and call it. And now we can tell the server to listen to a different port. So we can say HTTP server, and we can have it listen to a different port right here. So WebSocket is listening to 3001. We can have the HTTP server to listen to 3002. But if your application, your front end and your backend is such that you want everything to come to a same port, you can also do that. So to do that, we can just remove this particular port right here. And then this particular object, this options object in the WebSocket server, this also has another property called server. And you can pass this particular HTTP server here. Okay, so now what ends up happening is we also have the HTTP server as well as the socket server listening to the same port, which is 3002. Okay, so if I come back to the browser, you can see that it is not working, and that is because the client is listening to 3001. So if I were to change this and save, now you can see that the error went away, and now the same thing would still work fine. Okay, so now you can also write REST API endpoints using the HTTP server. So far, we've done the simple act of listening to the message event both on the server and the client side. Now I want to increase the complexity a little bit. If I come back to the browser, I have just created the same application instances in two different windows. So if I enter some message right here, hey there, Harish, and I hit send, you can see that it is not getting reflected to other windows right here. It is only getting reflected to this particular socket right here, right? But if we wanted to broadcast this message to other people in other windows as well, the current functionality does not allow that. So we will be seeing how to do that in the next section. In this section, what we're going to be doing is anytime a user on one side enters a particular message, it could be, hey there, John. We ideally want this message to be emitted to all the windows involved. And before we start doing that, let us just bring this particular input field and the button a little to the top so that we have some space to work under here. So coming back, and we have these styles right here. let's go to this area right here where we have the justify content. We can comment this out and then let's add a little bit of padding. Let's say 5 rems. Okay, so this should actually bring this to the very top. We can actually leave this as 0 because we only want the padding to be applied at the very top and the very bottom. Perfect. All right, let's get started. So as I said, if one user sends a particular message, we want all the users in all the different windows to be updated with the same message. Okay, so to do that, using this particular WS package is not going to be enough. Okay, because the WS package is very, very low level. It does not have the capability to, broadcast the messages to certain groups of people or everybody out of the box. We have to definitely manually configure it, which we don't want to do. So instead, we can just go ahead and use the library called socket.io. So let us go ahead and install that particular package. So let me go inside of server right here. We don't want to use this WS anymore. So first, what we can do is we can uninstall the WS package. Okay, so let's make sure that that's been removed. Yeah, it has been removed. Let us now install socket.io. Perfect. Now this has been installed as well. And there is also this one more thing that I noticed, which was we have this node mon sitting inside of the dependency, but actually this is a developer dependency. So let us actually move that here as well. Let's move the node mon to the developer dependency right here. And let's do a final npm install. So we have finally installed socket.io library right here. But first let's understand what the socket.io is and how is it better compared to the low level libraries out there. As I said, WebSockets are pretty low level and developing real-time applications require an additional layer over them, like the popular npm package called socket.io. So let's look at the features of socket.io. It allows us to fall back to HTTP long polling in case the WebSocket connection cannot be established. Let's look at the second one. Automatic reconnection in case the WebSocket connection gets closed. Acknowledgements to send some data and expect data from the other side. Broadcast to all or to a subset of connected clients. And this is very important. We might have a particular feature where we might want to broadcast a message to all the users or to a subset of connected users. Think about a WhatsApp group. And lastly, Socket.io allows us to scale up to multiple instances of the server. This can be very important when you're scaling your application to a large number of users. Okay. And finally, we have the connection recovery as well for short periods of disconnection. Anytime there is a disconnection happening, Socket.io library has what it takes to reconnect or recover the lost connection. And there is one more point to remember. If you use the Socket.io library as the WebSocket wrapper on the server side, you will also have to use Socket.io on the client side as well. And the reason why this is necessary is because Socket.io implements a custom protocol on top of WebSocket to provide additional features like automatic reconnection, long polling, broadcasting, coarse restrictions, etc. So if you're working with the browser API, which is the WebSocket API, and if you're working with the WS package, which is very low level, you do not have access to all these important things that is required for a production grade application. Because sometimes it might get disconnected and you want the library to take care of that reconnection, right? And if the socket were to fail, you want it to resort to HTTP polling. So let us now start rewriting the code. We do not want this particular line. We can destructure a method called server from socket.io. Okay. And now coming down, we currently do not want to use this WS right here. So instead of that, let's remove this entire thing. And now let's invoke this particular class right here, new server. And this takes in, as usual, we can pass in the HTTP server inside of this. Okay. And also as a second argument, this takes in an object right here. So inside of this object, as we just discussed earlier, socket.io also provides coarse restriction support. And right now, for the purpose of this tutorial, let us say coarse, and then the origin can be left as a star. So basically what this means is any client out there is able to hit this particular server right here. Let's also change the name of this server to IO. But if you're working in a production grade application, you ideally want to mention what are the client domains or client origins that you want Socket.io server to respond to. So for example, right now we know that the client is running on port 5500, right? So you can actually open up an array right here. You can also have multiple origins right here. So the first origin could be HTTP localhost port 5500. But for the purpose of this tutorial, let us just leave it as an empty star right here. Perfect. So now coming down, let us also rename the WS server to IO right here. And we can still leave this as is because the IO server still listens to this particular connection event right here. And here, let us do one more thing. Instead of logging the connection established message, I now want to console log a particular message. So I now want to console log the socket ID. Okay, so I can now say user with a particular socket ID is connected. Okay, so we can just say user with a particular socket ID connected. Now coming down, so we can still leave this line as is. We don't want to change it. But since we are working with socket IO, we wouldn't need these two lines. So let us remove this. Also, let us just console log this data right here. Okay, so we wouldn't be getting the buffer this time. We'll just be getting the data because we're using the socket IO library. And there is one more thing that I want to change here. So what the requirement here was that anytime a user sends a message, it should be propagated or it should be reflected across all the browsers or all the clients that are connected to the server, right? So to do that, we can't just be sending it back to the same socket. Okay, we have to send it to everybody, right? So to do that, we have to use this IO right here. And then we have to use this particular method called emit. And we can also name the same event, which is message. And this is where I can send the particular data back to the client. In addition to that, we also want to know who is the user that sent that information, right? We can also log the socket ID along with the data right here. So to do that, we can just say, let's open a string literal and then come down here and then we can include the socket ID. We also don't want it to be very long because the socket IDs can be very long. So let's use the substring method and we can just say 0 to 5. And finally, along with that, we can also now say data. Perfect. So let me close all of this up. So now it looks like the server side code is completely done. So let us now move on to the client side code. So now to be able to use socket IO right here, instead of the browser API, we first have to go to the index.html and then import the socket IO library right here. Okay, so to do that, I'm going to go to this particular link right here, which is the cdnjs.com/libraries/socket.io. And this is where you can find all the socket.io libraries for multiple purposes. So as you can see up here, we have the socket.io.js. But I do not want to use this particular CDN link because this is not minified. So let us actually go ahead and find some minified socket.io. Yeah, so we have it right here. Let us use this particular minified JS. So if you hover over here, you can either copy this particular URL or you can copy this entire script tag as well. Okay, because this might save us some time. So let me click on this and let me come down here and paste this right here. So if I save it, let me also close this up so you can see what is going on. Perfect. So what we've done here is that we've just copy pasted this entire script tag right here. So this is the link and it also attaches some integrity and cross origin and other properties right here. We can leave it as it is. And also just make sure that this script sits on top of this app.js because inside of this app.js, we will be using the socket.io, right? So this needs to be initialized before this is executed. Okay, perfect. So let us now go ahead and convert the browser API WebSocket to socket.io. So to do that, we can just say IO right here. So up here, we don't have to import this IO. It is already going to be available from this script tag right here. Okay. So now coming down, let us look at the send message function. So this particular socket send. So since we're using socket.io, let us now emit it. And let us also give it a particular name right here. It could be message. And we can leave this here as is. Let us come down. So what are we doing right here? So this socket is listening for the message event coming from the server, right? The server is emitting this message event, and then this client needs to grasp it. And since we're using socket IO now, let us call it on. And this is still going to be a message, and we have to get the data and then append it to the UL. So the rest of the code remains as is. Perfect. So, okay, so looks like all the code is rewritten. Let us also make sure that there aren't any error messages that are getting logged. No, there aren't any. So let us actually give this a whirl again. So we can say, hey there, Harish. Okay, press enter. Okay, it looks like we are not actually getting any message. So the reason why that is happening is that, so this is where the client captures the message coming from the server, right? So what has happened here is that we do not get the event object anymore right here, right? So the event object is something that we get when we use add event listener, but right now we're using socket IO. So in this case, we get the message straight away right here. Okay, so now it should work fine. So let me refresh the page again and let's say, hey there. Perfect. Now you can see that this is the socket ID and this particular user has sent hey there, and it is now emitted to all the browsers that are connected. So if I come to this particular socket, which is a different browser, so if I say, hey there, how are you? You can see that this is a different socket ID and that is getting reflected here as well. Perfect. So what we're seeing right now is the core feature of how chat applications work. So we are almost there. So in the next section, we will also see how to send these messages to other specific users. So right now what we're doing is, if there are 100 browsers connected, any message that is sent, it will go to all the 100 users, right? But what if there is a certain group that you've created and that group only has 10 users, right? In that case, whatever message that you send, it should only go to those 10 users, right? So we can do that with something called chat rooms in Socket.io. And in addition to that, we can also add some other nice functionalities like user typing, right? If somebody's typing right here, ideally we want the other people to know that this particular user is typing, right? And whenever the user stops typing, this should go away, right? So these are some nice additional functionalities that you can add to your chat app. We will see how to do that in the next section. Hello guys, welcome to this section. In this section, we will look at how to implement this thing right here. So anytime a user joins in, you can see that it says welcome to chat app. And because this user reloaded, you can see that this user disconnected and got reconnected with another socket ID. So we will see how to implement this. But in addition to that, we will also see how we can implement this beautiful activity tracker. So if a user were to type something, hey there, how are you? You can see that it beautifully types out this thing right here. And if I leave it idle for 2 to 3 seconds, it goes away, right? And similarly, if this user were to type something like, I am good, you can see that it shows the activity tracking right here. So we will see how we can implement all these things in this section. So before we get started with building out the activity deduction, let us quickly integrate Express into the server-side code base. So right now you can see that we are using the HTTP module that comes right out of the box with Node.js. But it is very limited, and in production grade applications, it is very likely that we might use a framework like Express. So we will also see how we can integrate that with Socket.io. So let's open up the terminal right here and let's just go ahead and install Express. And before I start using Express here, let us also change the imports from the older CommonJS import types to ES6 modules. So to do that, just come to the package.json file and just mention that the type needs to be module. So by default, it is going to be CommonJS, and let's now say modules. All right. So if I come to the server side, you can see that it has crashed because we're still using the older CommonJS syntax right here. So first up, let us replace this first with import server from Socket.io. And right now we don't want to work with the HTTP core module as well. We want to now use Express to spin up our HTTP server. So let us import Express from Express. And now let's get an instance of the Express server right here. Now we can also make it listen to the same port as HTTP server was listening to earlier. So we'll use the same port right here as well, and we don't need this anymore. Okay, so we're now listening to port 3001. And let's also move this hard-coded value to a different port, right? So if we were to deploy this particular code base to a server, it might have its own port, right? So if that is available, it might just take from that, or else we can just have it default to this particular port right here. So let us replace this. And this constant also takes in a callback. So we can say console log, and we can use a template literal here as well. And we can say server is now listening to, and we can use the dollar symbol right here. And we can specify this particular port. We can say server is now listening to port and whichever number that is. Perfect. Now coming down, you can see here that the socket IO server takes in the HTTP server, or at least an instance of the HTTP server, but we've completely removed it. So you should not make the mistake of using this app variable right here and pass it as the first argument to the socket server. This is not what you should do. So essentially this app is an instance of the Express application. Okay, it is used to define routes and middlewares and other application logic, and you can also use it to handle HTTP requests and response logic. That is what this is good for. But the socket server expects a HTTP server. So the HTTP server can be obtained by doing something like this. Okay, so as soon as you listen to a particular port, this function gives back the HTTP server. Okay, and that is what you have to send in right here. So let us just make sure that there aren't any errors in the server side. So looks like there aren't any errors. So now let's come back to what we were doing, which was to add the activity handler. So if one user were to be typing something, we want the other users to be notified of the same. So to do that, let me come to the client side code, and under the form right here, let me add a paragraph. So inside of this, we can say something like user is typing. So this is how it would look like. We want to be specific about which user is typing. We will handle that programmatically. So let us come back. Let us remove this because we'll be programmatically adding that here. Now, so let's think about it on a very high level, how to achieve this functionality. So let's say on this particular window right here, the user is typing, right? And all the other users should be notified of the same, that this particular user is typing, right? So as the user is typing, an event needs to be emitted from the client side, and it should reach the server, right? And the server should broadcast that message to every other user connected apart from the current user, right? That is what we have to do. So first off, let's start with emitting this event right here to the server. So let's take up the client side JavaScript right here. And how can we capture this information? So to achieve this, let us first start with listening on the key press event that happens when the user types on this particular input bar. So let's write the code right here. Let me close this up. So we need a reference to this particular input right here. So let us actually see if it has already been done. Yeah, we have it right here. So let us actually move this line to the very top, right? Let's move this line to the very top of the lexical scope, right? So this function would still have access to this input right here. And we can also share this across other functions here. So coming down, we can say input.add event listener, and we are listening to the key press event right here, right? So anytime the user presses something, we need to trigger a particular callback. So what do we have to do right now, right? So as a key press is happening, we immediately have to notify every other clients that this user is typing. So the information first has to go to the server, and the server has to now decide to send that information. So let's first emit a particular event from the client. Okay, so let's call that event name as, let's say, activity, right? Let's call it activity event. Okay, so let's emit that first. So to do that, we can say socket.emit, and let's call it activity. And inside of this activity, we can also send the socket ID. So for that, you can go ahead and say socket.id, and we can still pass in only the first 5 characters of the socket ID because they tend to be a little long, right? So we can say substring right here again. So the client side code is done. On key press, we are emitting this activity event to the server. So the next step is we have to capture the activity event, right? So let us go to the server side code right here. So coming down here, inside of this particular callback, we can now listen for the activity event right here. And we will do that in a minute. But before that, there are a couple of things that I want to do. So for example, let us say this user loads up this particular web page and enters this chat box. So as soon as the user enters this particular chat box, we want some notification here as a message saying that you have entered this chat box. Okay, so let us do that. So let us do a comment right here upon connection, right? And we can also say only to current user, right? And to achieve this, we can use the same socket keyword right here and then emit a certain message. And for the actual message, we can say welcome to chat app. Similarly, as soon as a user joins, we also want that notification to go to other users, right? So let us also do that. So we can say upon connection to all other users, right? So we can also do that, but the syntax is going to be slightly different. So in this case, we are still going to use this particular socket, but we are going to broadcast the message and then emit it right here. So basically, what is the difference between socket.emit and socket.broadcast.emit is that the socket.emit directly goes to the current user, whereas socket.broadcast.emit goes to everybody else apart from the current user. Okay, so that is the only difference. So let us again send a message for the data right here. We can now say user, and let's open this dollar syntax right here, and we can still pass in the same data right here, and we can then say connected. So let me close this up so that you can see it properly. Perfect. So every other user is going to get this information saying that user number whatever is connected. We also want to listen for another thing. Let's say a user disconnects, closes the window and goes away. So that needs to be notified to everybody else, right? So let's do that as well. So upon disconnection to all other users. So we are going to be using the same message right here as well. But in this case, we're going to say disconnected. That is the only difference. So let us now listen to the activity event that is coming from the client. So let us capture it right here, right? Capturing the activity event, right? So how can we capture it? So we can again say socket.on activity, and this gives you the name, right? So if I come back to the client, you can see that as a message, we are actually passing in the socket ID. So we can call the socket ID as the username as well, right? So as soon as the server receives this activity event, we want to broadcast it to everybody else apart from the current user, right? So what we can do is we can say socket broadcast emit, and now we can again emit this particular activity event back to the client, right? So we can again pass in the name right here. Perfect. So we've successfully captured the activity event on the server side, and now the server has to broadcast that message. So we have emitted that here as well. So the next step here is to capture that event on the client side. Okay, so remember, so far we've just emitted it, right? Now we have to capture that event on the client side. So to capture it, we can again say socket.on, and then we can capture the activity event right here. And here we get a callback function. We also receive the name right here. And the next step here is to add that the user is typing inside of this paragraph. So let us actually quickly get the reference to the paragraph text right here. So we can again say document.query selector, and we're getting the reference to the only paragraph tag that we have currently. So let us come down here, and now we can say p.text content is going to be, and we can open up a string literal here, and we can say that this particular socket ID or the name is typing. Perfect. Also, we don't want this message to always be present. Let's say this particular user types something, we show the message in all the other clients, but the minute the user sends something, we want to remove this particular text, right? So let us do that. So this is the message right here. So let us come down here, and then we can again get a reference of this P because we've initialized it here, and we can now say text content is going to be an empty string. So there is still one problem with this, but let us actually give this a whirl and see what has happened so far. So if I come back here, okay, looks like the server is not running yet. So let me actually start the server back again. And now you can see that two windows have been connected. Perfect. Two windows are connected. And also both the users have received the first message, which is welcome to chat app. And looks like this user loaded up first. So this user has gotten the message, user with this particular socket ID is connected. But actually this should not exist right here because the user never got disconnected. Okay, so let's see where we went wrong on the server side code. Okay, so this is the line that actually sends that message disconnected. Okay, so it looks like we're triggering this particular message event to the client as soon as the socket is established, but this is not how we have to do it. Okay, so let me just rewrite it a little bit. So firstly, what we're doing is we have to listen for the disconnect event. Okay, and only inside of that, we have to call this particular message right here. It shouldn't be on the outside. So let me now restart the server again and let's come back here. Okay, perfect. Now you can see that we don't get the disconnected message and both the users get the welcome to chat app and welcome to chat app. And it looks like this window loaded up first. We get this notification right here saying that this user just got connected. So if I restart this particular window, you can see that this user got disconnected and this user got reconnected again with a different socket ID. So let us now test out the activity trigger. If this user types something like, hey, you can see that it shows that this user is typing. So if I send, you can see that it goes away. And similar to that, if this user types in, how are you? You can see that it still says typing and we can send it. But there is one more problem that I face right here, which is if I were to type something, hey, and then I don't send it, I just like leave it as it is, it might confuse everybody else thinking that I am typing some huge paragraph. So we don't want to leave anybody hanging like that, right? So what we can do is after like 1 or 2 seconds of being idle, we can remove this activity message in all the clients. Okay, so to do that, let's come to the client side JavaScript. Let me pull this down. Let's come down to the activity listener right here. And what I'm going to do is I'm going to, using let, I'm going to create an activity timer like that. Okay, so as soon as the activity event is triggered, we are setting this particular link in this text content, right? So what we want to do is if this activity event is not triggered for at least like 2 or 3 seconds, we have to remove this back. Okay, so let's put a comment right here saying that clear after 3 seconds, right? So let me type out the code first and then explain. So I'm going to say clear timeout and I can pass in the activity timer inside of that. So coming down, I can say activity timer is going to be set timeout. And inside of that, I can say 3000. And inside of this, I can set the text content to empty string like so. So what are we doing right here? So anytime the client is picking up on the activity event, it is setting this particular string, right? But if it has not received activity event for at least like 2 or 3 seconds, we are removing it. And we are clearing the activity timer every time the activity event is triggered because we do not want to set up multiple set timeouts. So now let's see this in action. Let me refresh this page. And now if I say, hey, and if I leave it for like 3 seconds, it should ideally go away, right? And if I send it also, it should go away. On this window, I can say, how are you? And you can see that it would stay here for like 3 seconds because I'm idle and it would still go away. I also want to do a few final touch-ups right here in the UI. So if I type something right here, you can see that this activity tracking is not so aesthetically pleasing, right? The socket ID is very long and it's overlapping on this particular message. So to fix this, let's come to the client side code right here, come below here, and this is where we're emitting the activity event. So here it looks like I've just put the substring right here. I haven't mentioned the first 5 characters, right? And now you should be able to see a very short looking socket ID right here, right? Perfect. Also, let's now style this paragraph tag. Okay. So to do that, I'm going to come to the styles.css and come down here. I'm just going to paste a few paragraph styles. So all of this code is already in the GitHub repository. So let's come back to the browser. And if I type, hey there, you can see that it is beautiful right here, right? The text is italicized and there's a right amount of padding and margin. Perfect. And regarding the time where we clear this out, right now it is set to 3 seconds. You can also decrease it to 1 or 2 seconds if you want. So in the next part of this playlist, we will look at the two most important parts working with Socket.io, which is working with chat rooms, connecting to specific rooms with specific people talking about specific topics, and more importantly, we will be building it with React.js. So I'm pretty excited, and I'll see you there in the next video.